Well, good evening and welcome everybody. My name is Obi-Wan Piz. This is N-Simplex Pachinko, and we are currently without music, so hooray. When it decides to work properly, it will work properly. But for right now, I may end up just switching over to the web-based version. I have a web-based version. Sorry, YouTube-based version. Which honestly, I kind of don't like it, but if you've got to, sometimes you just got to. Jeez.
I don't wanna just get by in life before we die.
That was a little much. Sorry.
No chances to revive.
Okay, so alternatively, this is also a slightly different music set. So that also makes it a little more interesting. Alrighty. Well, anyway, thanks for coming in, and I hope everybody's having a good start to your week. Kids have gone back to school. I've been having a little bit more time to read and totally read. And trying to beat Expedition 33, because my goodness. I also definitely could not play that with them in the house. I've also taken the treasurer role of the scout troop, so we gotta get that going. The treasurer role of my kids' school's parent group is I have been doing that for a year, and I still don't have access to their bank account, so I keep sending stuff to the old person and saying, hey, you still need to do this because you haven't gotten me the paperwork. It's a good time. I'm sure I have read this at some point. Good times. We'll just clean that off. So tonight is, in fact, a Peter Liljedahl night where we are working through yet another chapter of Building Thinking Classrooms. This is a specifically for K-12 teachers type of session, but anybody can get cool information from it if you're at all interested. I do not recommend getting the book unless you are somebody who actually is going to use it, i.e. teaching math, or potentially teaching other subjects, or potentially you have a math teacher in your life, and this might make an interesting present for them. But, I don't know what... Okay. But here is... That is not where I wanted to be. This is the link to the book if anybody is actually genuinely interested. Again, I don't recommend it unless you are a math teacher, are a teacher who's looking into different ways, methods of teaching, and or you are buying it for a math teacher. So, Zach brought up Homework, Oh Homework, a poem by Jack Proletsky. I probably am not going to scan this very well, but we'll see how it goes. Homework, oh homework, I hate you, you stink. I wish I could wash you away in the sink. If only a bomb would explode you to bits. Homework, oh homework, you're giving me fits. I'd rather take baths with a man-eating shark, or wrestle a lion alone in the dark, eat spinach and liver, pet 10 porcupines, than tackle the homework my teacher assigns. Homework, oh homework, you're last on my list. I simply can't see why you even exist. If you just disappeared, it would tickle me pink. Homework, oh homework, I hate you. You stink. Thank you, Zach. Yeah, so, like, what's the prevailing thought on homework? Of course, the answer is, depends on who you're talking to, depends on when you're talking to them. If it's at the end of the semester, believe me, even teachers hate it too. I bet. I'm sure mine would, absolutely, too. I shouldn't do that. So what does homework look like in a thinking classroom? So naturally, we've got a whole bunch of problems that come up when people just talk about homework in general. My biggest problem, I think, was just the easy one. Students don't do the assignment, just as written. Do not do. Really? Come on, man. Having some problems with. Man, I'm having some problems with this entire computer over here, so maybe we'll just have to close all the Firefox windows and let Windows figure out what exactly it wants to do with its life before trying again. So I may be slightly less responsive to chat for the next, like, 2 to 5 minutes, who knows. Okay. So, problems. Students just don't do the assignments as written. There are various reasons for this, and there are various methods by which they don't do the homework. Right? What are the goals that anybody actually has for homework? So, you know, why do teachers assign it in the first place? So we all know the big one. So one of the major goals here is that students will do the homework as a method of practice to make sure that they understand what it is that they're doing and how to do it. Thank you so much for the follow. Be back in a couple of minutes over there. We're getting there. Such a slow computer. I probably need to nuke the thing and start over on Windows 10. Which means probably going back to Windows 7 and upgrading to 10. The thought was I keep that one on Windows so that I'd be able to, like, use the stuff, but we're getting to the point where Linux might be the best option for that one too. We're gonna have to use probably Ubuntu with the like long-lasting service pack or whatever, and then this one can be upgraded to whatever. That's me. Yeah, just use Linux. I mean, yeah, right. I like the freedom that the Linux is offering me over here, and quite possibly I'm gonna switch this particular one over to one of the more science-friendly ones. So I've heard good things about maybe Mint or there's at least one or two other builds that distributions that are like more science oriented, so I might upgrade this one to do that. Fedora. Right. So anyway, so we want to discuss a little bit more about what the problems are in terms of students not doing the assignments, why, by what methods are they not doing the assignments, and how can we mitigate any of those issues. The goals for homework, again, most times teachers will say outright that they want their students to practice skills, to reinforce learning. So they're not going to forget what they learned that one day if they bring it over. You're from Poland. You are a student. Tomorrow a test. Quadratic functions. Sure. Nope. Wait. I need that. Do not throw the stylus in the book as your bookmarker, because you do, in fact, need the stylus. So, Stefsio, we have the quadratic functions, can be thought of in a number of ways. So the most basic one, what I call the parent function, the simplest form of the quadratic function is going to be y equals x squared. So there's a number of different representations we can make for this. One is the equation. Another is our relationship between inputs and outputs. So we have our x's and our y's based on those pieces of information right there. We know that if we just plug in some numbers, -3, -2, -1, 0, 1, 2, 3, wow. Boy. That our outputs for this are going to be that number multiplied by itself. So -3 times -3 is +9. -2 times -2 is +4. -1 times -1 is +1. 0 times 0 is 0. Then 1, 4, and 9 on the opposite side. We could also come up with the most basic version of the graph. Right, where we have a point at 0, 0, 1, 1, 2, 4, and 3, 9. Right, negative 1, 1, negative 2, 4, and negative 3, 9. And while we're doing all this, this is going to flatten out as it gets towards 0, and then start steepening as we move out from there. Okay. So this is our basic parent function of the quadratic function. If we would like to do some sort of transformations on this, typically the transformations that I have worked with, nope, are going to look, roughly speaking, like this. We have our variables, x and y. We have the structure, in that this is a square function. And then all of the different possibilities that could potentially exist for function transformations are these: the a, the b, the c, and the d. A is going to be a vertical stretch. If you multiply by a number on the outside, you're taking its y value and it gets multiplied further and further from our x-axis. Alright, B is a horizontal compression factor. C is a horizontal shift, and D is a vertical shift. So in theory, we could have something that looks like y equals 3 times the quantity. Let's go a half times x minus 2, all in parentheses, squared, minus 1. Now, the way that I do this is a bit different from many other people. However, the basic idea is that we're going to look at where all of these values have gone to. Where have they been shifted to? Where have they been multiplied to after all of this stuff has been applied to them? So one way to do it is you take the actual table that we created up there and start manipulating it based on the stuff that's here. This might be a little complicated and a little bit in-depth for what we're doing here, but for the more adventurous types, I would suggest the stuff that you are inputting to the function this time is all of the stuff that's being squared. So your 1/2 parentheses x minus 2 is all being squared. These are the values that get us the nice numbers, -3 through +3, as integers. right? Now, those were just, again, the numbers that were up there. And again, this is that stuff squared. So a half parentheses x minus 2 is here. We need to build the function. So we have here 9, 4, 1, 0, 1, 4, 9. Off to the left, what we're going to do is we're going to take all of our inputs and find out what the inputs are now going to be, or rather, where have those nice points from up here been moved to? So these points here are no longer going to be in these locations on this graph. They're going to be changed based on these operations. So what we need to do going left is to uncover x. What we need to do on the right is to build y. Because right now, the y that we have, the output from the square function, is just that set of parentheses. The other things, the 3 and the minus 1, aren't there. So we need to do that. You essentially go by order of operations. So going here, we're going to build up y by saying, okay, we need to first multiply by 3. So that gets us 27. 12, 3, 0, 3, 12, 27. And then all of this is going to be 3 times the quantity, 1/2 times the quantity, x minus 2 squared minus 1. So the actual y values that we're going to get, because this is y equals all that stuff, we've now built the equation. Subtract 1 from everything that was over there. 27 becomes 26. 12 now becomes 11. 3 becomes 2. 0 is negative 1. And then this is symmetric, so we'll just copy those values down there. Now, Stefcio, this may not be exactly what you had in mind, and that's okay. We'll get to more stuff in just a little bit. Here, in order to uncover x, we need to multiply by 2 in order to get the 1/2 off this thing, and that becomes x minus 2. So when we multiply by 2, all of the x values now become negative 6, negative 4, negative 2, 0, 2, 4, 6. And then moving one more, we're going to add 2 in order to get x. So if we add 2, this is going to be a negative 4, negative 2, 0, 2, 4, 6, 8. And so this is it. These are our x values. And these are our y values. So the nice points at, again, this thing was negative 3, negative 2, negative 1, 9, 4, 1, etc. Terrible. Alright, have been moved here. So, negative 4, 26, negative 2, 11, 0, 2, 2, negative 1, 4, 2, 6, 11, 8, 26. And we can graph. So this goes from negative 4 to positive 8. It's fine. 8, 4, copy that distance here, negative 4, negative 2, positive 6. And now we get values that go between -1 and positive 26, right? So let's go like 32 up at the top, because 32 is a nice number to split in half, and in half, and in half. 24, come on. Alright, so that's 28. That's 20. That is going to be 12. That's going to be 4. Okay. So, we have here, again, -4, 26. It's right about there. And it's nice to label these, especially if it's not obvious what they are. -2, 11. If you have a table of values sitting like right next to the graph, don't worry about actually labeling them, except maybe a couple of points just to show your teacher that, yeah, I do in fact know what I'm doing. 2 -1s. This is like way down here. So that's basically what I can see as well. Okay, good. This is 0, 2 here, 2, -1, 4, 2, 6, 11, and 8, 26. Right, and then for this, we'll just do the best we can to graph all these like that. Close, real close. Okay, so then this becomes y equals 3 parentheses 1/2 times x minus 2 squared minus 1. Okay. Now the other way that I would do graphing, just me, is that like all this is really well and good. This is a very analytical way to do it, and if you like analytical stuff, awesome. You're going to understand how to figure out what, how to shift a particular function, how to stretch a particular function based on this fairly easily. Again, start with what's the function you have. So this is a square function. So take the stuff that's being squared, uncover x. Take the stuff that is being squared and start building up the equation to get y. Once you have the two extremes, you have your x, you have your y. Those are your points. The other way that I do it, which is based on looking at the parent function, if you already know what the parent function is, just right off the top of your head, there's a nice, easy way to figure all this stuff out. 1. How far did we shift? We shifted horizontally in the direction opposite the sign. That's given inside the parentheses there. Whereas vertically is going to be the same sign as the direction we shift. So this means that with a -2 here, we have shifted 2 spaces to the right. With a -1 here, we have shifted 1 space downward. So we take all of our basic parent functions, we shift them right 2, down 1. Sorry, all of our basic parent points, the parent function points. Again, shift right 2, down 1. Then we're going to look at this and say, what are the standard distances that we normally work with? Well, from the origin point, which is the vertex, right? The vertex is at 0, 0. So beyond what we just shifted, it doesn't move, because vertical stretch and horizontal compression is a multiplier, and you're multiplying zeros. So nothing changes. So we're at 0, 0. We move right 2, and we move down 1. We are now at 2, -1 for our vertex. And in fact, you see right there, we have 2, -1. So 2, -1 becomes our first point. Then from here, what normally happens is we go sideways 1 and up 1. Both directions, sideways 1, up 1, to get to the next point. Well, in here, we just had a horizontal compression. The factor is 1/2. So we're compressing this function horizontally half as much as we normally do. So it kind of relaxes outward by an x factor of 2. So here, you'll notice that our points have now gone from 1 space away from the origin point to now 2 spaces away. Instead of going from 2 to 3, it goes from 2 to 4. And the vertical distance normally was 1 up. But now, because we have a multiplier of 3 in the front, it's a vertical stretch factor of 3. It is now stretched vertically 3 times as far. So instead of going over 1, up 1, we're now going over 2, up 3. And up 3 from -1 gets us to +2. So from 2, we go in either direction. We go 2 spaces. It gets us to 0, and it gets us to 4. Then from -1, we have a vertical stretch factor of 3. So instead of up 1, we go up 1, 2, 3. So -1 plus 3 gets us to 2. So 0, 2, 4, 2. Same for the other ones, right? Over 2 up 4 becomes now over 2 times 2 gets us over 4. And up, instead of up 4, it's now tripled. So 4, 8, 12. So 12 plus our -1 gets us a y value of 11 when we go an extra 2 spaces beyond what we just had. Thank you for the follow, by the way. Awesome to have more people in. Right, so we end up going to -2, 11 and +6, 11. Honestly, I don't even pay that much attention to where the points are in terms of like what its actual values are until I'm done. It's sort of registering in the back of my mind. But here, right here, I would have said, okay, my origin point is at 2, -1, cool. And then we have a horizontal compression factor of 1/2. So we're going, instead of over 1, we're going to go over 2. It doubles the horizontal distances. Then we're tripling the vertical distances. So instead of going up 1, we can now go up 3. So 1, 2, 3. Oops. 1, 2, 3. There we go. And we get to this point here. And I put that point in, again, without even labeling it most of the time. And I go, okay, from there, we go over 2 and another 2. Up 12 puts us here. Put that point in. Here, we go 2, 4, 6. Over 3, doubled, is now over 6. And then up, normally this is 9, and it gets tripled to 27. So a distance of 27 from this point is going to be up here. Put in that point. And then I say, oh look, the other side is mirrored because this is symmetric. Right, so we also have line of symmetry is where the vertex is. It is a vertical line. So, what is the same on a vertical line? Nothing ever changes when we go straight up and down in the horizontal direction. So our x value is fixed. That is going to be, in this case, x equals 2. Also, I most of the time you don't see a b here in function transformation or equations involving quadratics. Most of the time you don't see a b factor. Reason being that we could have let this be in 3 times, we could have split those two multiplied terms, the 1/2 and the x minus 2. So it could have been 1/2 squared times x minus 2 squared minus 1. Then a half squared is a fourth, which then would get us 3/4 times x minus 2 parentheses squared minus 1. That is the exact same function, right? This is the exact same equation as the one above. It's just in a slightly different form because we knocked out all of the constants from the square bit. And if we wanted to really go with this, we could also show that if we went over 1 over to here to 3, that we would only end up going upward 3/4. So this would be at 3, negative 1/4. And if you don't believe me, plug it in. And here's the kicker, right? We could go over 2, up 4. But now, because we're multiplying by a vertical stretch factor of 3/4, we take that distance of 4 that we would normally go and multiply 4 by 3/4. And now our vertical distance becomes 3, and oh, wouldn't you know, we're back in the same spot again, 4, 2. We went from the origin point right to up 4 times 3/4. So up 3. And then same deal on the next one. This would be over 3 up 9, but then 9 times 3/4 is going to be 27/4. 27/4 puts us at 7 3/4. Right, so that's going to be 5, 27/4. And then again, we could go over another one. So this would be 1, 2, 3, 4. Normally it's over 4 up 16, but then we multiply by 3/4 and it's up 12. So again, we're at 6, 11. So you can do either of these. Either keep the b value, or if you had a really inconvenient number that was on the outside, but it was a perfect square, you could pull that in and say that that is now my horizontal compression factor instead of being a square number on the outside. So instead of being a here 1/4 on the outside, we also had it as a 1/2 on the inside. Okay. Next. This is going to be a bit of a crash course, so sorry, but you got some hours to study, I suppose. If we want to, we could take that thing that we have up there and multiply it all out. I don't necessarily recommend this, but it works. So the one we have up above is y equals 3/4. We'll just keep this one instead of going with the 1/2. That makes it harder. Okay, multiply by x minus 2 parentheses squared. So x minus 2 parentheses squared is x minus 2 times x minus 2. Which, if you remember your multiplication, right, this is just as good as running a Punnett square in biology. X minus 2, x minus 2, x squared, negative 2x, positive 4. Add them all up. Those do not have any like... no, okay. The x's are like terms, so we can add them together. We end up with x squared minus 4x minus plus 4. And then a minus 1 still on the outside of all that. And then multiply. So this is now going to be 3/4 x squared minus 3x plus 3 minus 1. So y equals 3/4 x squared minus 3x plus 2. Okay. This is usually going to be called like polynomial form. A lot of people like to use the word standard form. However, the problem is that across borders, standard means completely different things. So usually this is also called general form. Or your nearest local equivalent. Whereas this one up here usually that lower one is what's called vertex form, because you can see where the vertex is. It's at 2, 1. And the a value is 3/4. Up in transformations form, it's a little bit harder to work with, a little bit harder to see, but, you know, it works out okay. Normally, I'm not terribly averse to showing people where this all comes from. So if we have something in vertex form, we multiply this all out.
You're watching a toothbrush play,
There we go. Alright, so multiply in your a. So here we have an ax squared minus 2ac plus ac squared plus d. And we're going to kind of group together the things that have... Oh, wait. 2cx. 2acx. Yeah, missed that part. That's important. All right, that's better. So, this is how all of this would be portrayed. Oh, you know what? I don't like doing that. Sorry. I'm going to change. Sorry. What we're going to do is we're going to change our variables here for the vertex form to h and k. Typically, this ends up working out a little bit better because you're not going to get confused on other random stuff. So, okay. Specifically, The issue is that the general form of a quadratic is going to look like y equals ax squared plus bx plus c. And if I just wrote down all this stuff using a's, b's, and c's, that is actually terribly confusing. So I would not blame you on that part. Okay. Now, there's a few things that you can do in order to find various... Yep, no worries. There's a few things that you can do to find, and as always, if you need to catch up on the VOD, feel free. There's a few things to do to get properties. So one is to look for your intercepts. Right, so your vertical intercept is the place where it touches the vertical axis. That is where x is equal to 0. So your vertical intercept is going to be 0, comma, and then when you plug in 0 for your x's here and here, that only leaves this stuff at the end. So that's ah squared plus k. Now, me personally, that's not terribly convenient. So doing a vertical intercept from vertex form, not particularly nice. It's okay, but it doesn't really work all that well. Doing a vertical intercept in general form, again, plug in 0 for x. That eliminates the x here and the x here, leaving just c. It's like it was made for it. Right? General form is great for finding out your vertical intercept. All right, horizontal intercept. And we could, in fact, have multiple. We saw on this graph, for instance, we have multiple horizontal intercepts. One here at about 1, and one here at like just after 3, 3.5, something like that. We don't know what they are exactly, but it doesn't matter right this second. So what we can do is we look at this and we say, all right, how can we get 0 for our y value? Well, this is going to be 0 equals ax squared plus bx plus c. That's not really a nice thing to do. So right here we have to wait a minute and we'll come back to it. Now there are some good news pieces of this. One is that we now have this equation in general form. So that means that we could say that this is going to be y equals, like general, y equals ax squared minus 2ahx plus ah squared plus k. This means that well, this is still a, because we've got only a in front of the x squared. The stuff in front of x is all b. And the stuff that's out here, that's a constant, is c. So we could rewrite this. A is a, so don't need to change anything. B is equal to negative 2ah. And c is equal to ah squared plus k. Okay, we'll hold on to those for later. the horizontal intercept or intercepts here. For this one, we can go all the way back up to the top there into vertex form. Y equals a times the quantity x minus h squared plus k. We can set this equal to 0, because again, we want the places where y is equal to 0 for our horizontal intercepts.
YouTube Music Premium. Listen to ad-free songs.
Okay, 0 is equal to all that stuff. And then what we're trying to do is solve for x. So subtract k from both sides. It's going to be negative k is equal to a times the quantity x minus h parentheses squared, all divided by a. Okay, so parentheses x minus h squared is equal to negative k over a. Now, in order for this to be nice, to be numbers like we had up above, k over a has to be negative so that the sign in front ends up flipping it back to become positive. We can deal with that in a minute. But you know what? No, it's fine. Either that means that a is positive and our function is going up like this, and our k is negative, which means that our vertex has to be in the negative region. That should make sense. Because again, if it's going to be facing up like this, we want to know when it's going to cross the x-axis. So shift it down, and it's going to cross the x-axis. Alternatively, if a is negative, it's angled this way, then we end up with the logical conclusion that our k value must be positive to bring that up. So if our k value is positive and our a is negative, that fraction is negative, and the negative then flips it to become positive again. Reason being, we're taking the square root. When you take a square root, you've got to have a positive number on the inside to have regular real numbers. We'll talk about what that means in a minute. So here, the absolute value of x minus h is going to be equal to the square root of negative k over a. Absolute value means that regardless of what sign the stuff on the inside has, regardless of the sign of whatever's on the inside, the square root over there is going to end up being positive. The value of the stuff on the inside is this positive square root. So, in order to say what's the stuff on the inside, we wanted to know what the distance between x and h is, effectively is what this is also asking. So, if we want to know what x and h could have been to make this thing, then we could have had that x minus h was the positive square root of negative k over a, or it could have been the negative square root of negative k over a. Doesn't actually matter. Then we add h to both sides. Descendant. Good evening and welcome. And we get h plus or minus square root of negative k over a. This is so ridiculously simple. Right? Because now all I have to do is say, hey, remember that example that we had earlier? If I want to find the horizontal intercepts of this particular thing, all I needed to do was say our x values were equal to h was the horizontal shift of our vertex, which was 2, plus or minus the square root of negative k was the vertical value, which was a -1 over what our a value was, which again was 3/4. So yeah, we're going to get a fraction, but that's fine. So x is equal to 2 plus or minus. This negative negative becomes positive, and the 3/4, we can multiply both top and bottom of the inside of the radical by 4/4. It is a form of 1, and that's going to clear out the compound fraction on the lower part, and then the top part just becomes 4. So now it's just 4/3. Again, shouldn't be a surprise, right? X is equal to 2 plus or minus. Here, you could split the square root and give it to each top and bottom. It's a radical. It's also a fractional exponent of 1/2. So square root 4 over square root 3. It's going to be x is equal to 2 plus or minus 2 over root 3. And realistically what that means is our x-intercepts, again, here are going to be 2 plus 2 over root 3, comma 0, and 2 minus 2 over root 3, comma 0. 2 cosine 120? If you're doing it in... If you're doing it in... So normally, sines and cosines, you're not talking about this particularly, but sines and cosines are going to be limited to using two-dimensional representations, so that we have right, we're going to have two outputs for our answers here. So it works if you're going to be using complex numbers. So right now we don't have use for complex numbers, so it's fine. Don't worry about it. Okay, so we can now find what the zeros are going to be, or what the x-intercepts are going to be. Your teacher probably wants you to rationalize denominators and all this other stuff. Fine, I guess. My point really is that if you understand the transformations stuff, all of the rest of this ends up like coming out of it. So you don't have to necessarily memorize a whole bunch of stuff, right? You could start from basic principles. I know what my transformation form for quadratics looks like. From here, we can now build all the rest of it. And in the other side here, we had that our x was equal to h plus or minus the square root of negative k over a. Now, we have h's and k's that we can solve for. So in this one right here, h is equal to a negative b over 2a. How properties behave. I mean, yes. Right, and then we use this compounded with that h over there to solve for k. So k is going to be equal to, this is c minus a times h squared, which is parentheses negative b over 2a squared, which is k is equal to c minus a times b squared over 4a squared. Okay, that a and that a can divide out, and so we get c minus b squared over 4a. Wish you were struggling on this and not the stuff you're currently learning. What is it? Dare I ask? And then we can multiply the c by 4a over 4a. So this becomes 4ac.
That's ASANA.com.
Did I just... No, we're good. 4ac over 4a combined with you rip it away right when I'm getting to the good part. Alright, I should have been more diligent about looking for ads. We'll come back. Give it a couple minutes. Yeah, we're gonna go downstairs and grab something, so like 2 minutes. Alright, Stepsio, good luck. Have fun with your exam. Okay, last bit for anybody who's still awake on this one. Right, we just took a whole bunch of stuff. We said that our general form of the polynomial is here, y equals ax squared plus bx plus c. We said that if we took the vertex form, y equals a times the quantity x minus h parentheses squared plus k, and expand it out to general form, we can do that. And we now relate this with that, and we get this thing. So b is now equal to, because it's the same thing as negative 2ah, c is equal to AH squared plus C, AH squared plus X. No, C is equal to AH squared plus K. It's written right there. And then when we went back, we saw that now we could solve our x-intercepts for h plus or minus square root of negative k over a. So we can take these things, solve them for h and solve them for k, and now plug them back in to this thing. Or, well, this thing, I suppose. It's the same. So, last little bit. We're going to take all these little bits here, bring them all together, and we end up with x is equal to h is negative b over 2a, plus or minus square root negative k is 4ac minus b squared over 4a all over a. That's still inside the square root there. Blech. Gross. We hit compound fractions. So multiply both top and bottom by 4a inside the square root. X is equal to negative b over 2a plus or minus square root. Bring the negative into the top. B squared minus 4ac all over 4a squared. Okay, split the square root again. Negative b over 2a plus or minus square root b squared minus 4ac all over square root of 4a squared, which is 2a. By the way, this, right, this is h. This is the x value of the vertex. This it's the distance traveled horizontally, so only in the x direction.
With YouTube Music Premium, listen to your favorite songs ad-free. Download music and podcasts to listen
Distance
to
traveled in the
live
x direction
podcasts.
from the vertex
Enjoy
to
songs
the
from customized playlists and radio stations.
intercepts.
And jam to music when your screen is off or while using other apps. There's more to discover with YouTube Music Premium. Try 1 month free of charge.
Yeah, of course you're going to work now. Because I threatened you. Punk. Learning about rational maps to irreducible varieties. Nice. That's apparently still not working. Alright, cool. Cool. Has a higher chance of working in a couple minutes. And quite possibly blasting everybody's ears, so probably not. Anyway. So, Welcome to the quadratic form, our formula that you all know and love and can sing Pop Goes the Weasel to. At any rate, that is how we work out quadratics. And then for now, we're going to take all this stuff and shift it over there. Okay. So, marker. Sort of. That's really frustrating. Just want the damn thing to play. Like, that's the weirdest thing about Spotify as well when it's on the web app. Now, I don't know if it's just because I'm using Firefox and it doesn't like Firefox, because all sorts of things do not like other technologies for whatever reason, and they just won't do anything. And it still says I'm on the previous track that I played like 3 days ago. That's a lie, it was yesterday. So if we close this, and then we back over here, and go to copyright free music playlist, go this way. Will it work any better? Probably not, but you know what? I'll take probably not. All right. So what we're actually going to be working on tonight. No. So seriously, I do say that if anybody has any questions, please stop me. We'll come back to the other stuff some other time. So it's not a big deal. We are at this point. Yeah, it's only 10:20, so I mean it's not like it's a huge deal. So, what are the problems with homework? And like anybody who was a student at some point can chime in whenever you feel like it. So, students aren't doing the assignments for whatever reason it may be, or it's done inadequately when it is done. And a lot of times we see this as not having any particular motivation to do this thing, or they have mistaken the purpose of homework. So for teachers, again, we talked about this. We want students to practice the skills that they were given. We want them to reinforce the learning that was done in the lesson. There's probably a few more in there, but it is not just like some busy work, or it is pretty much the last thing a teacher really wants to think about is whether or not this thing is graded. Most of the time it is done, right? It is being graded, but not because the teacher likes grading so much as they are able to offer feedback to the students. The whole like grading system and how much it counts and you know, pretty much everything that has to do with homework that does not give the student if the purpose of that particular homework is not for one of these things, you know, the teacher may have to do grades, but that's like an end result sort of thing. This is not something that the teachers generally are thinking about right on day one, as in like, yeah, let's get to grading. Like, most of the time, creating this hierarchical structure within the classroom is antithetical to actually creating a good classroom culture. When it starts becoming competitive, or when students are like, you know what, you're just going to give me an F anyway, so like whatever, I'm not going to bother. You know, it doesn't help anybody. Okay. So we'll just leave all of it up. So I'm going to take notes as we go through. And once again, sort of the way that I do this is we're going to read through what Peter Liljedahl says about his particular study and what he's found over the years. I will interject with little bits and pieces of stuff that I've found. For the most part, we are going to let the expert in the room speak, who is Peter Liljedahl. And I don't know anywhere near as much as he does about this subject. One, obviously, he wrote the book on it, quite literally. Two, I only actually attempted this, like the full thing, for one semester. I did attempt to do like the thinking activities at the beginning and some of the lessons throughout over the previous 1 year. So we'll see how this goes. There you go. All right. Chapter 7, What Homework Looks Like in a Thinking Classroom. Of the hundreds of teachers whose classrooms I have visited and the thousands of teachers I have worked with, almost all of them give homework. Almost all of them struggle with its effectiveness. In this chapter, we read about the role that homework plays in mathematics classrooms, how students engage with it, and how this aligns to the intentions of the teacher. Along the way, you'll be introduced to the limitations of the current institutionalized notion of homework, and by the end of the chapter, you'll learn about an alternative conception that puts thinking and student responsibility back into homework. All right, the issue. Homework in its current institutionalized normative form as daily iterative practice to be done at home does not work. Almost every teacher I've interviewed says the exact same thing. The students who need to do their homework don't, and the ones who do their homework are the ones who don't really need to do it. It's a broken construct that long ago lost the good intention under which it was conceived. If I ask a teacher, what homework is for, I almost always get the same answer. Homework is a chance for students to test their understanding, right. Hang on. There was an important word in there that I missed. That was actually quite important. Teachers say homework is for students to test their understanding, to learn from their mistakes, and to find what they need more help with. Okay. When I ask students what homework is for, they tell me that it is for marks. Not exclusively, but overwhelmingly, students say that homework is for grades. When asked, whom is it for? The students will, again, overwhelmingly say it is for the teacher. And when asked why it is assigned, they tell me it's for practice. Obviously, this creates a huge disconnect between what teachers want and students see as the objectives of homework, what homework is actually for. So what's causing the disconnect? What are the implications for teaching and learning mathematics in general, and for our thinking classrooms in particular? Before beginning to experiment with alternative forms of homework, we first decided to take a very close look at how students were engaging with more institutionally normative forms of homework. As we did with the research on studenting behaviors for the Now You Try One tasks that were presented in the introduction, we wanted to know what the spectrum of studenting behaviors was for homework. So, we spent time talking to and interviewing students in classrooms where teachers gave homework as a list of questions to be done at home. In some of these classrooms, homework was worth marks and some of it was not. What emerged from this research was a set of four basic studenting behaviors. Didn't do it. Cheated. Got help. I hate got help. And tried it on their own. Right? Much like the studenting behaviors that were found in a classroom when activities were given. We had students who didn't bother. We had students who stalled, but by doing stuff that wasn't really related to academics at all in the first place, right? They go for a walk, they go to the bathroom, they go get food, they, go do a whole bunch of other stuff, come back, and then copy down everything that was on the board. You've got students who stalled, but did on-task sorts of behaviors, like looking for their pencil, trying to look around for something, asking people questions, which wasn't necessarily related to this particular assignment in this particular, activity, but nonetheless, they were out there trying to get some sort of information that was at least related to mathematics. And then the tried it. Now, the didn't do it group broke into 4 subgroups that were essentially individual, tailored reasons why they didn't do it. So again, this isn't necessarily they were absolutely slacking and just hate math and didn't bother. There are some genuine reasons, like number 1, legitimately busy. Suck. Should not be having this problem. Okay. Legitimately busy. So, younger students had multiple activities after school, and naturally that leads them to not be able to just sit down and dedicate time to doing homework. Older students. Older students had multiple classes giving homework. They also had activities. Jobs. Socializing. All right. Second reason why they just didn't do it. They're just forgetful. All right. Man. It's ridiculous. Okay. And being forgetful also has two sort of breakout bits to it. The first is that homework to some of them just wasn't a priority. For whatever reason, right? There's a myriad of other reasons why homework isn't important to them. And there's a few that are also covered in other sections of this. Or poor record keeping practices. So they were supposed to do their homework, but they just forgot about it because they relied on their memory rather than writing it down, rather than actually pulling out their date book to make sure that they got their homework done beforehand, to make sure that they started it well ahead of time, all that stuff. Okay. Third reason that students just didn't do their homework was that they don't know how. Which again is its own problem and feeds into a couple of the other things down below. But if they just didn't do it, a bunch of them, and he says this is at least more common, is that they don't know how, which could be masking where they're saying, like, it's one of those reasons up there, right? Oh, I just forgot. Or, oh man, I had so much stuff after school, all this stuff. But Peter said that through interviews, he was able to get some of these students to, to admit that, okay, look, I told my teacher that I had a lot of other stuff to do, but honestly, I got busy reading because I prefer doing that instead, and I don't know how to do it, and that's my problem. So the ones who said, I actually don't know how, even though I'm making all these excuses, are part of this group here. And at its core, not knowing how to do it is typically the most legitimate reason. and can be corrected. Right? We can target this particular behavior and start saying, okay, if students actually don't know how to do it, let's figure out why students don't know how to do it. Let's cut through all the BS that they say, that, oh, well, you know, it's because of the 50 other reasons that I gave you. Cut through it and say, no, no. Let's try and actually figure out why it is that you're not happy with this particular homework, why it is that you're struggling, and let's try and actually, you know, solve the problem, as it were. Really? All right, and the last group here is they just don't want to do it. It's a hassle. It's a pain in the rear. And again, this can feed into many of the other stuff. Right? It can break into... oh, man. It's not worth points, or at least not enough points to bother. Let's see. And when randomly, like, you pick a day of the week ahead of time without telling anybody, and I'm going to check the homework on this particular day for this particular class, you know, roll the dice. Maybe you always do 1 to 3 problems, and sometimes a student is like, you know what, I've done homework for the last 3 weeks. I probably don't need to do it tomorrow. You know, they've got enough social capital, they've got enough grade capital that they can just afford to skip it for a day, because I just don't feel like it. Not doing their homework was something that was unique to middle and high school students. The behavior was seen with almost equal distribution in all classes where homework was assigned, irrespective of grade level, irrespective of, nope, just irrespective of grade level. All right.
Get an exclusive deal on a brand new 75 plate car today. Visit marshall.co.uk.
Anyway. All right. Group 2, they just outright cheated. So, Peter says, if you ever want to have a good day, ask a middle school or high school student to tell you about some of the ways in which they cheat in other teachers' classes. Totally not yours. They definitely don't cheat in your class. Some students are amazingly innovative and industrious and are often keen to share some of their brilliance when it comes to cheating. When it comes to homework, cheating predictably includes copying from someone else, or borrowing somebody else's work, right? So this is actually copying somebody else's work onto your own sheet of paper, or literally just taking somebody else's, replacing their name with yours and handing it in. In some cases, this is done with historical homework. But ingenuity goes well beyond some of these tried and true methods. A number of students were interviewed and admitted that they had access to an entire binder of worked homework solutions from students who had taken the same course with the same teacher in the past. I got two songs going on, hang on. Yeah, you did. Anyway. Right? Something that obviously only works when teachers use the same homework problems year after year after year. Even more industriously, several students had pages in their binder ready to go if there was a homework check. They flipped to that page, it was covered in dense mathematics, had some diagrams, graphs, and when the teacher walked up and down the aisles checking the students had done their homework, these students would display some of these pages in lieu of actual homework. We were told by these students it almost always works, and if it didn't, they had an out. If the teacher noticed that it was the wrong homework, they just start flipping back and forth and being like, oh, it is? Oh, I just never noticed. Randomly flip back and forth in their binder until the teacher becomes impatient and walks away. Unbeknownst to us, we witnessed this working twice. Only after homework check had happened did these students reveal to us what they had actually done. So, false pages, right? You just have a page that has just a bunch of like notes and stuff, worked out problems from the back of the book or something. Or again, borrowed from somebody else or what have you. So, students will figure out ways to cheat that are beyond anything. The most innovative form of cheating we witnessed, however, were students who had the same course with the same teacher but were in different blocks. So they shared their binder or their workbook, and the students had protocols for division of labor that went well beyond homework and included even note-taking and test review pages. And again, these students had shared their binder and their workbook and whatever, so that they were using literally the same stuff, just handing it back and forth. So they're doing basically half as much work, give or take. Let's see. Regardless of the method of cheating, any student who admitted to cheating was asked to explain why they did it. The least common, but the most interesting, was that some students just cheated because it was fun. They liked the subterfuge and the excitement. More common was that they just didn't know how to do the work. Cheating for a lot of these students. Hey, Marlena. I'm sorry to force you to enwetten your computer. Right? In order to entertain themselves, it has to be exciting, and it has to be some sort of like, I'm going to innovate a new way to cheat. I'm going to see if I can get away with this. I'm going to see if whatever. Yeah, it's a good way to get in trouble, but nonetheless. Yup. And I mean, from a teacher's perspective, right? Like, yeah, sure, plenty of students handed in fake stuff to me and things like that. Plenty of students handed in stuff that obviously was not their work. Those were intended to be handed in to the administration and be like, all right, well, if you cheat on multiple assignments, you are going to go through this disciplinary process, and it's not going to be pleasant, and whatever, blah, blah, blah. Sure, fine, whatever. The ones that were more egregious, like they used... there were a few that I was asked to sit in on to do, like, interviews and make sure that things were above board and didn't get too confrontational or anything like that. But the idea was, like, I sat in a couple of them where the teacher said, like, okay, so here is your test, and you say, blah, blah, you understand how to do this, yeah? Okay, great. Explain it to me. That was often my most fun moments, were watching the student go with, yes, okay, please explain. Like, you don't even have to get it 100% right. Just explain to me, like, what your thought process is as you're going through all this stuff. There were several students who it was like, okay, so here's your test, and here's what I pulled up on Mathway, or like, some other algebra solver that does all of the individual steps for you. Photomath. Photomath got really big. We're doing okay. How about you? So yeah, they got pretty innovative. As soon as a new technology came out, they were on top of it, already cheating with it. And it was like, why do you even bother? Some of the other ones, I look down at the paper and I'm like, I don't even know how you did this. And then, like, I pull up Mathway and go, yeah, it's right there. Like, that's how you do it. And some of them were really wild. It was like taking a, fifth degree polynomial and then ending up working out some, like, 3-term thing by 3-term thing that you would have had to do a method that we didn't teach. Um, and every single time we were just like, look, your teacher asked you to solve it by this method. I understand if you learned it this way because you did it by rote memorization based on what, Mathway or Photomath are saying to do. But, we basically told you not to do that, and the teacher gave you multiple different ways of doing it. So, if you wouldn't mind, here's a pen and paper, go. Redo it. Right now. Like, without, it took away the notes and things like that, and we're saying, here's a new problem. Go for it. So many just, like, stared at us, and we're like, yeah, I just don't know how to do it. It's like, okay, well... There was one or two students who insisted that they did know how to do it, but the problem was that they had done, rote memorization, and so they just didn't know how to do it anymore because it was like 2 days after the exam. Guess what? That means he didn't learn it. So, I don't really care what you're claiming. If you can't do it 2 days after, like, you deserve at least an F. Okay. But in order to prevent most of this stuff, we will give little slaps on the wrist for doing this sort of thing on homework, because it's a homework thing, right? I'm not going to worry too much about it. It's when you start getting into, like, the stuff that's actually graded for actual points that we say, yeah, no, this isn't going to work. This is getting into disciplinary territory. And, if you do it again in the homework, then we're going to not accelerate. Boo. Yep. Escalate. There we go. We're going to escalate this to the next level or whatever. So, cheating for pretty much all of these students is a masking technique for a lack of ability. Which seems intuitive, right? He might not be able to get away with saying that in a room full of psychologists, but but in a room full of math teachers, yeah. And especially, again, like I said, he's had 15 years with 400 plus teachers. Like, he knows, at the very least, what he's talking about in terms of, like, what the students have told him and what the teachers have told him. So, it was always like, well, look, this student got, when they went back and did something, like I said, when they went back and reevaluated, then they fail. So clearly, the person does not have the ability to complete this, but decided to instead cheat because they felt that in a lot of cases it was worth the risk. They wanted to be able to, say, hey, these are the consequences, sure, but what are the consequences of getting bad grades? And they know what those consequences are. They don't necessarily know what the consequences are for cheating. It's like they may have heard of it before, or they might have, seen somebody else get caught, and they're like, nah, but I won't get caught. Becoming as blatant as that poor Jumbotron couple. Oh, I'm a part of a online trivia league called Learned League. And we have a nightly Oh, are they? Really? Okay. They have a nightly trivia contest, which goes on for weekdays for 4 weeks. 6. 1, 2, 3. 1, 2, 3, 4, 5. Okay, so it's like 5 full weeks, 24, 25 actual days. Oh, are you kidding me? Don't worry. So yeah, I joined Liljedahl League because of one of my friends, and he always names our private rundle. So the group that you're in and you're playing against is called a rundle. So our private rundle, which is just like us and our friends, is called this time the Kiss Cam Strikes Back.
Shame. Shame.
Thank you, Famished.
Shame.
We've done a few other ridiculous ones, like what was it, last year, 2 years ago, when Liz Truss was the Prime Minister of the UK. I believe we were something to do with head of lettuce. Like the head of lettuce that beat Liz Truss or something ridiculous like that. Like that was the name of our private rundle. So he changes it every time to be something related to like current events. But the main rundle that you're in pits you against all of the other people in your immediate area, like, however it selects them. It was doing it with time zone for a while. But it was also like, when you joined, these are the people that you're paired up with. And you kind of come up with them as a cohort. And then when you're done with your first season, you go and you join based on, you join the E rank, and then D, C, B, A. If you're really, if you keep winning in each of your ranks, you keep getting moved up. And like a football league, for example, the top 2 people, I think, move up a rank, and the bottom 2 people move down a rank. So I have been shuffled back and forth, pretty much staying in C rank almost exclusively. And then you assign points to your opponents 0, 1, 1, 2, 2, 3, based on how you think they will do. So the 3-pointer you want to give to them in a category that's like, I think they're not going to get it because they've got like a 10% in art. And this is a question about a statue. Like, you have to figure out what category it probably belongs in, and then look at your opponent's scores, and then assign points. So it gets kind of interesting. But yeah, I'm very much a C rank trivia nerd. My spouse is a very much B rank trivia nerd, and then like every time she goes up to A, she's like, "Oh, this is gonna be awful," because she just loses every single time. And it's just like, this person is getting 9 points from 6 questions, which is the maximum. 9 points from 6 questions every single time. So she's just like, I just can't can't stay in A. So she keeps getting knocked back down to B, and then like, I'm gonna have a much nicer time this time around. So most people try, I don't care, but most people try during the last couple of weeks to figure out where exactly they're going to fall. If they're really close to the bottom and they don't want to get knocked down, they just try harder and like look back at old questions that this person has answered and try to see if like an old question is something similar to, does this person have a freakishly good knowledge of the Titanic? But like the rest of their world and US history is miserable, right? Like, how exactly does that work? How exactly does that play? Anyway, thank you, Zach, for getting me back on. Totally, 100%. That's what you meant to do. We were just talking about Trivia League. Okay, so. Although cheating was a behavior that we saw more in grades 6 through 12, there was also some cases of cheating in students as young as grade 2. In these cases, the most common form of cheating was just copying from somebody else, and which was something that other peers were very reluctant to allow. You are back, trivially. Because if you've never spent time with the younger kids, like second grade-ish, the sense of fairness and the sense of ownership is very strong amongst these groups. So allowing even your best friend in the whole wide world... ads. I'll continue that thought in a minute. Oh, get some nice pops in here too. Choke up a little bit on these, because they are actually far too long, far too heavy. Well, not so much too heavy, but they have too much force in them. Too much momentum. Been popping the tendon right in here. It keeps like crossing with the other one, and then every time I do something like one of these moves, especially like twisting, basically it pops the two tendons apart from, or like as if they're crossed and then moving past each other. So not terribly comfortable. Alright, let's do probably one of the lower belt forms in Tangsudo Karate, and then we'll do one of the upper belt forms as well. So, let's do green belt. Pinon 3, I think. This is one that... No, that's not it. Oh, man. Okay, we do a Fugel inside-out block, followed by step up, and this is a dual block. So we kind of come this way, block this way, then we come back this way and swap, back and swap, and then we step the other way to do Fugel inside-out block. Oops, Fugel inside-out block, step up. Then we come to the front and do a cross block down, and then a twin fist out, and then a pierce. Okay, now you're going to lose me from the camera. So from here, we have to basically we do a pierce, we grab, and did I do this wrong? I think that's right. Back and chop. We go into Kima stance, so it's like a horse stance. So we came off of there, did a cross block, twin fist, pierce, wrap, chop. Right, so then from here, we have to turn to the front, and we block something above our heads, like a cross block sort of thing. Come back to the hips. Alright, this is where it gets a little bit interesting. So, we have to take a right crescent kick, bring it down, and then we are parrying with our shoulder, which is a very strange thing to do. Basically, you're parrying with your shoulder, and then you do a back fist, bring your hand back, and then you do a crescent kick, parry, back fist. We're going to lose that again, lose a room. Alright, back fist, and then a crescent kick, parry, back fist, step, and punch, and then we come around and both elbow and punch over this shoulder, and then jump and do the same over the other shoulder. It's a very weird form. So Pinon 3 is, like I said, green belt. It's sort of the first... It's really the first form that isn't just using the exact same I formation. Because like Tego 1, when you learn from white belt, you do down block, right, punch, down block, punch, down block, punch, 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 and then you do another down block, punch, down block, punch, down block, punch, 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 down block, punch, down block, punch, return. So you go like start left, go right, to the center, up the middle, to the, from your perspective, left, right, middle, center, left, right, return. And Tego 2 is the same thing, only you replace a couple of moves. Tego 3 is the same thing, but you replace a couple of moves. And then we get the Pinons, which are basically the same but more advanced moves. And then Pinon 2 is like the same as the other ones with the I formation, but then at the ends there, instead of making an I formation, you come 45 degrees in like an arrow, and then you make an arrow out here too, and so it's a little bit different, but honestly, it's not that different. How does any of this relate to normally co-ambient co-topologies? I mean, there are certainly some homologous structures here in terms of making sure that I'm doing the karate correctly. But honestly, it's just to keep our heart rate up. Gotta sweat a little bit. So, and then we have black belt form that I've been working on for goddamn ever. Basai Dai. Oh, that's not good. Oh no. Well, I got the front part of it good. So, come into the... Oh, that's right. We go here. Ooh, nope. Here. Return. Up block. Pierce. Like that. Crescent. Down. There. And then come around. Do a duel. Well, apart from just forgetting a little bit. Yeah. Somebody put that on one of the one of the clips we did. It was like, go ahead, divide by 0. All right. Well, that is what, roughly speaking, 17 years worth of practice will get you, followed by a year off. So, I have been, unfortunately, not training Tang Soo Do. But I have been doing eskrima, which is what the sticks were from, and Tai Chi. So my eskrima instructor is like primarily a Tai Chi instructor, and that's like he's been to the Philippines multiple times, and then also to Malaysia multiple times to learn from the masters. Like to go get his ass kicked. That was his entire goal. It was like, oh, okay. I mean, pretty much the longer you're in martial arts, the more likely you are to do that sort of thing. I just don't feel any special pull to go and get myself clobbered, especially since the masters that I know here are quite capable. So if I ever get to the point where I'm so good that I might actually need somebody else to fight against, then maybe. But no, that's not going to happen. I started when I was out of college, so like it's a bit late for me. I don't want to say that as being just a naysayer whatever, but, you know, I'm like 20 years behind everybody else, so. Okay, 15. I'll still join the community. We'll still have some fun, but I'm not gonna be one of the people who like starts getting ready to go to, you know, Myanmar, being like, hey, let's go. I heard there's a guy doing a seminar next weekend. Okay. So I was in the middle of a sentence when ads cut me off. The most common form of cheating amongst second graders was copying from a peer, which was something that peers were very reluctant to allow, because if you remember yourself, or if you've spent time around those particular kids, their sense of ownership and their sense of fairness are like extremely heightened. So even your best friend in the whole wide world might not be able to get your homework in order to just copy it. Right? Like, my best friend, I would have been like, dude, just do it yourself. It'll take you 5 minutes. But when talking to those students who cheated, you know, the very young kids, they did it primarily because they forgot to do their homework and they wanted to avoid disappointing their teacher. Because again, their sense of fairness and their sense of the other thing I said, ownership, is second maybe only to their sense of not wanting to disappoint adults. Okay. And then, group 3. Yeah, it is also slightly sad. Because, like, if I have... It's pretty much any time that I taught, right? My purpose was to go and make sure that the students were primarily just making an attempt and being honest about it. So, you know, you screwed up, you didn't do it, whatever, fine. Just hand it in late. I don't really care. What I care about is that you're attempting it before you get to the exam time where you have to do it. You have to get it right. So make your mistakes now. Go online, do the work on the thing, and make sure that you're actually doing it. Right? Now, I will say, my martial arts, sloppy. Why? Because I don't practice. This is my practice time. Right? Like, I practice with people. But there's another thing that... there's another decent analogy that we can use for it, and that is... lifting weights. Because I'm not going to expect a second grader to be able to lift this thing. This is 20 pounds, right? That's like half their body weight. So you don't want them to be like, I can't do whatever skill. Okay, fine. I'm not asking you to do the applied mathematics that's all the way at the end of the thing. I'm asking you to do the legwork that leads up to it. This is a 5-pounder, right? So start working on this, and you're going to have to work on your own muscles, your own brain, in order to make sure that you can do the things that you need so that when the time comes, you will look at this, and maybe it is a little daunting, but it is not actually that difficult because you've done the framework, you've done the legwork to get up to this level. so that this is not that hard. So the students tend to understand that, at least, and be like, okay, well, I understand the concept of lifting weights. At least, you know, most of my community college students were happy to understand that particular analogy. Okay. And the third group here got help. So the students who went and got help on their homework. This is not something that is just generally speaking like they got advice on how to do something and then they went and did it. For the most part. Some of those students, maybe. So Peter says, students often get help with their studies. From homework to preparing for tests, some students routinely seek help from peers, parents, tutors, and teachers. This is neither unexpected nor uncommon, right? I mean, pretty much everybody at some point is going to get help from somebody in order to make sure that they understand something correctly. What was interesting, though, was the reason behind and the results of getting help. When asked why they sought help, almost all students claim because it was because they didn't know how to do the work. I'm seeing a trend. Honestly, I mean, you'd have to be like not listening in order to in order to miss this one, right? We've had it in the other two groups as well. The students didn't know how to do it. So what did they do? They cheated to get it done. What did they do? They just didn't bother. What did they do? They got help. The students didn't know what to do for the assignment. So guess what the fourth group is going to do? They're just going to try it on their own first, before they seek other help and before they try to do whatever else. They just try it. And of those who did just try it on their own, we'll get to talking about this later, but take a think back. Those of you who have been here for a while or you've seen the previous episodes of this series, think back to the ways in which students complete the assignments in class. The people who are in the tried it on their own group fall into two of those categories. And again, if you remember the pie chart or the percentages of the number of students who are in these groups, think about it for a minute and try to figure out which two groups I'm referring to. It'll be pretty obvious once we get there, but okay. So the students who got help, first of all, admitted they didn't know how to do it. So they went and they got their help. There were a few cases where working with peers, parents, tutors, or their teacher was just part of their daily routine in the first place. So, fine. Regardless of help actually being needed at the time. So again, that's fine. When students who did get help from a tutor or parent were asked how they would do if a pop quiz were given tomorrow based on that homework, 90% of them said they would fail. right? This is less than 24 hours, possibly even less than 12 from when they worked on their homework. So, like, what are we doing? That's kind of what he's asking. So what did they end up getting help with? They got help with getting the work done, not with actually learning anything. So this is the problem, or yet another problem, is that they see this completing the assignment essentially as a checkbox. This checkbox needs to be checked, and I need to make sure that it gets checked. So how do I do that? I get help. I get help with a tutor, a parent, or a teacher, or whoever, even just another one of my peers who seems to know that they, what they're doing. And I don't need help learning because that's too hard. Often. Right? There are some students who would genuinely want to understand it, but for the most part, right, a vast majority of these students, I guarantee, would just be in this mode where they're like, I just need to complete the assignment. It just needs to get done. I don't care how it works, right? If I need to remember it in a week, okay, sure, I'll try and understand it. But again, how are they learning it? What is it that they're doing? They're learning enough to get it done. So again, what group does that fit in? Drilling deeper into the data, it turns out that the exceptions to these rules were the students who worked with adults as part of their homework routine, whether or not it was needed. These routines seem to be responsible for a lower number of elementary and middle school students who said they would fail a quiz outright. For them, the likelihood was that they have a homework routine with their parents, and that, the likelihood that they have a homework routine with their parents was much higher, and hence the results were better. The other exception was the students who had homework routines that involved working with peers, if they were allowed to work with peers on their homework. So like, we meet during third period, we have a study hall together, all of us work on the assignment together, we talk about it. All of whom said that they would pass the pop quiz on the next day. Regardless of what actually would happen, right? These pop quizzes were theoretical. They were not actually they were not actually a thing necessarily. But the point is that their confidence level is much higher. They were working with their peers on the assignment. So that's also an interesting fact, right? Why would it be that these students who worked with peer groups regularly, just saying like, as a matter of routine, I'm going to work with my friends on this homework every single day or every single week or whatever it was. I have a homework routine that involves my peers. they have a 100% report rate that they will be able to pass the pop quiz the next day. Again, theoretically, because there is no pop quiz, necessarily. I'm sure some of their classes did. But a 100% report rate, given that they had a 90% report rate in the other direction for, like, most students who got help from adults. Right? And again, Peter thinks that the other 10% were people who were getting routine help from parents or teachers or tutors. Right, and he's saying that that's in the data. I don't have any reason to doubt him. And especially since, like, this particular claim really holds no weight in terms of, like, you know, some of the pieces in here kind of hinge on the data bending a certain way, but, like, I don't think it helps this book sell better. If it's just like, you know, these other 10% of students who do get help from a tutor or parent get routine help, or like most of the other 10% get routine help sessions, regardless of whether or not they need the help. They are still there. Okay? Does that mean, is it something to be skeptical about? I don't really know. Like, you could sure enough, you could always say, I don't know about that, I need to see the data. That would be a helpful statement. But to refuse it, to just be like, no, I think he's lying, like, that'd be a little weird. Okay. So group 4, they tried it on their own. The rest of the students tried the homework on their own. Some completed, some did not. That is, again, not surprising. Regardless, they did not say they forgot, they cheated, or they got help from somebody else in trying it on their own. Alright, so these students, that was not what I wanted. I was apparently writing these. These do not belong to any of the previous groups. And reported trying it at some point by themselves. Regularly. Now, it could be that they just don't have a peer group that does homework. It could be that they don't have a tutor, they don't have regular time to meet with their teacher, or whatever else is going on. So there's no necessarily statement that's going to help explain them any better. It's just, these are students who do not fit into the above groups. Again, they didn't forget about the assignment, they didn't cheat, and they didn't get help. They just tried it on their own at some point. Again, some completed, some did not. Of these students, the vast majority completed the homework by Take a guess. Again, if you don't know the vocabulary word for it, that's perfectly fine. It's the same way that I did my homework all through middle of college when I realized that this doesn't work for me anymore. It is same thing we talked about before. The behavior where you go through, you look for the example in the book which matches the thing that you're doing now. You find the example in your notes that matches the thing you're doing now, and you say, what do I need to replace in order to make this turn into that one? It was the exact same way that I learned most of my mathematics. Right? People wonder why I dropped out of... no. So I was originally a physics major, and I don't think that it clicked yet in terms of my physics, that I can't just look at an example and then fill in the blanks with the things that I'm comfortable with. I just can't go through and, like, look at the example and then do the problem that's here. It does not work like that. None of the real-world examples work like that. None of, the homework after a certain point work like that. You've got to come up with your own problems. Right? Like, how do I reduce the friction of this thing with the blah, 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 whatever. You got two parts, they got friction on them. What do? You can't just look at other examples and be like, hey, let's try that, because maybe this is in space. So adding oil isn't going to work. It's going to freeze, or it's going to boil, or it's going to catch on fire, or it's going to dissipate. Right? Like, you can't just do something that's already been done. You're going to have to come up with maybe a brand new novel idea that you have not come up with yet. And so, like, how do you do math in a way that it looks novel? Or at least to you it is. Now, to your teacher might know 100% that you are not doing anything novel. Any method that you could choose, any method under the sun, it's not going to be novel. It's novel to you, but it's not novel to everybody, to mathematics, to the human endeavor of mathematics. Right? And then eventually what we do is we rope in everybody and say, hey, look, okay, all of you who have been doing all of this stuff over here, that have been like creating your own little notations and things like that. Awesome job. But guess what? Here's how the real notation works. Some of you have come up with an actual structure all by yourself to do this. You called it, function. You called it f. Guess what? That's a logarithm. We'll go over the history of it. We'll talk a little bit about it. Hell, even better. Joe, you like history, right? Cool. Why don't you look up the history of logarithms? That'll be your assignment for tomorrow. Okay. So, the vast majority of these students completed the assignment by mimicking. So they went into their book, they went into their notes, they went into whatever resources they had. Some of them went online, and they looked for an exact example of what they are now doing, and they copied one-to-one the steps that were done to get from A to B to B to C to C to D to D to E, etc. That was interesting. And as discussed in Chapter 1, When asked about this, every single one of these students said that they thought this is what they were supposed to be doing. And in fact, this mimicking behavior was such a dominant strategy that when the examples run out, so did their ability. All of the students interviewed who used mimicking as a strategy to complete their homework on their own, of all of them, less than 20% were even willing to move beyond this strategy when the examples ran out, and less than half of those were able to answer the questions for which an analog did not exist in their notes or the textbook. So, for instance, if you're given a similar problem to the stuff that the textbook has, start from vertex form, find out in terms of h and k what the quadratic formula is. They would have no idea how to do this. They would be so lost. Find the quadratic formula in terms of h and k. Guess what? It's right here. It's right here. That's it. So many of them, if it wasn't explicitly laid out in their book, if I asked the question, take this form and turn it into general form, they would not have any clue how to do it. Right, examples ran out, so did the ability. Right, so again, less than 20% were willing to move beyond the strategy, and less than half of those were able to answer questions for which an example was not explicitly given. I was part of that 10%. So I was willing, because I was interested in mathematics. Once the examples ran out, I was like, well, that's inconvenient, but I can do it, probably. And so I'd try and call back to other things, and I'd be like, okay, so what's the overall pattern? And I would learn some of it, or at least most of it, and be able to figure out, like, okay, well, this sort of works like this other one over here. I just have to modify it a little bit, and oh, look at that, it turned into the other problem. And then I was able to do it, even without looking at the other one. It was kind of like, okay, now I've got it. So like I said, I was part of that 10% of students who used mimicking, who then were able to continue on after. It did not serve me well over the years. However, it served me well enough until sophomore year of college. Like I said, once we hit differential equations, which is my favorite class, by the way, now, to teach and to learn. I'm actually doing a bunch of stuff on tensor calc. I finally figured some stuff out. Anyway, so yeah, it was my favorite strategy to use until differential equations, where I just like hit a brick wall because there were not enough examples to cover all eventualities. There were just too many. And so I just kept getting lost over and over and over again. And it was not until, probably the end of sophomore year when I got mono and also started dating my spouse, the woman who is now my spouse. It wasn't until like she had a much larger influence on me that was like she was working in the math center, and like I would go to her just on off hours and be like, can you explain this thing to me? Or I was like, I don't understand this, like, you know, this little section here, what's this about? And she would ask questions, not tell me an answer, not tell me like you need to work on this particular skill. It was like, okay, what do you see? What are, like, taking a sort of chemistry example, right? What has a higher energy form? And then what can you do to it to get it into a lower energy form? Because I like physics, I like chemistry pretty well. So there was a lot of discussion, a lot of asking questions, and that kind of formed one of the bases for the way that I teach, or taught, I should say, until I started doing Liljedahl. But even my one-on-one stuff, when I'm standing next to a student and I'm asking them, you know, I still ask the same things that she did. It's, what do you see? And then what can be, like, moved to become something that you know how to work with? What can be changed? What rules do you know concerning this thing? Oh, you don't know any rules? Okay, well, let's work with this thing, and we'll go a little bit further. So, I also occasionally go on about the fact that when I did my teaching demonstration, there was doing a lesson in front of people, and then there was also doing a one-on-one session with somebody. And so I took a red marker and gave him the green marker, and he would go through a whole bunch of stuff, and I would, you know, keep asking questions and prod and move and stuff like that. And I was absolutely insufferable when when the lady who was doing my one-on-one sat back down, I held up the marker like this, and I was like, and how much ink did I use? Because there was zero red ink anywhere on the board. I was like, absolutely insufferable. I would never do that today. But I kind of made a point of it because I was 25, 27, something like that. And it was just kind of like, you know, this is what I'm all about. The way in which I want to teach this stuff is that I want to make sure that everybody understands, right? I want everybody to, I guess, be the master of their own destiny, if they will. And so I was just constantly like, okay, you are going to do all the writing. I'm going to sit back and I'm going to ask questions, and I'll prod and move you along. Generally speaking, my teaching style is what's called Socratic, and so you follow the you follow the script of Socrates when he was talking with all of his interlocutors about all of the little philosophical things that he was talking about, where you say like, oh, well, this is what you believe. So if you believe that, then what about this? And you bring up essentially a contradiction. And they'd be like, oh, yeah, that doesn't work. Okay, let's go back and revisit this and try and tease out all the little parts that don't work and then make them work. And then I would again be able to come in and be like, okay, so if you change that, then this also changes this other thing. So it worked, especially on one-on-one. It did not work incredibly well in a group setting. So when I was trying to teach an entire class, then we've got a problem because now all of the students are like, well, I can just sit here and let these two people talk it out and like do whatever I want. And then when it's time to understand what's going on the board, I could just copy it. So, kind coming into the Liljedahl stuff was like, fit like a glove, because it was just like, it works with all the little things that I had been learning about over the years. And again, realizing that my method was not really working for everybody was kind of an important thing. Okay. So, among 200 students in grades 4 through 12 that were interviewed, these 4 behaviors, not doing it, cheating, getting help, and doing it on their own, were distributed almost evenly in classrooms where homework was marked. Now, this does contrast a bit in comparison with the behaviors that we were talking about at the beginning of the first session, where it was slacking. So students who literally did nothing was about 10% of the class, or of the typical class. Approximately 10%, so like 1 or 2 students most of the time. There was the stallers, who generally speaking did not want to do the work or didn't want to think about it, but would then do off-task stuff. So again, go for a walk, go to the bathroom, eat food, talk with their friends about non-mathy stuff, all sorts of other behaviors like that. I got like a mustache hair that is curling into my nose, and it is driving me nuts. I'm sure everybody wanted to know. So there is the slacking, again, no work, nothing at all. And then you've got the stallers, who are doing off-task behavior. It was about 20%. And then you've got the on-task stallers that they called fakers, who were pretending to do their work, or pretending to do something that was on task, but in order to stall for time so that the teacher would just go over it. Again, about 20%, which leaves the other 50% of the class to be mostly it wasn't quite that, but anyway. Oh, it was like 10% were the just do it. Okay. About 40% of the class were mimickers. So they were just like, we're just going to mimic, do everything by the literal book. Exactly how the book does it. And again, if the book goes beyond what the examples are, then, oh no, we're done. So, as contrasted with that, where almost half the class was mimicking, here you have this almost even distribution of homework completion in not bothering, cheating, getting help, and doing it on their own. Almost even. And when homework was not marked, I believe... Yep. Imagine that. Almost no cheating. Right? I mean, it makes sense, right? There's no incentive to cheat because you don't have to show off your homework. Maybe there's a couple of people who did it for social points. They wanted to make the teacher think that they were still doing the work in order to make sure that they were in good standing with the teacher. But most of those people just did the work anyway. There weren't going to be many people who decided to cheat because they wanted social points and that's it. almost all of the cheaters wanted points. And here, when it's not marked, they don't bother. The number of students who did not do their homework increased, naturally. So too did the number of students who just worked on it. So that's an interesting point as well. The cheaters split into two groups. Those who just tried it anyway, and those who never were going to do it anyway. That is, in situations where homework was marked, approximately 50% didn't do it or cheated. When homework was not marked, this percentage drops approximately to 40%. Not marking homework had a positive effect on how many students just tried it. Yes, and that is exactly the group that I had. Because in a lot of cases, I did not do some of the teaching behaviors that they were used to. And I didn't have a whole lot in the way of homework. So like, you know, I would give them a list and be like, you need to do this, but I'm not grading it, or the ones that I do grade, it's going to be just, you know, on a random day or something like that. I found it to be kind of a waste of everybody's time, quite frankly. If you're not going to do it, then you're not going to do it. And I don't want to grade it if I'm telling you, look, you need to go lift your 5-pound weight, and you don't want to do it. I'm not going to listen to you crying when you can't lift your 50-pound weight because you didn't practice. You didn't do the early weightlifting in order to get the heavy stuff. And I mean, like, I warned them that it would happen, and almost every single time, without fail. Anyway. Numbers vary between elementary and secondary students. More elementary students getting help than secondary students, and fewer in the forgetting or cheating categories in elementary. There doesn't seem to be any sort of linear deterioration in the way homework is approached as students get older, but it is clear that when marks start to matter, the students and their parents the marks start to matter to the students and their parents, the homework behavior changes markedly for the worse. So yeah, getting help was about 30%, did it on their own was 22, didn't bother was 25, and cheated was about 23. I mean, that is like an unbelievably high rate. And then when the homework was not marked, about 29% were getting help, so about the same. 31% did it on their own, which is a marked improvement from 22. Cheating went down to 2%, so it dropped by 20. The overall percentage dropped by 21%, down from 23 to 2. And that 21% then split, essentially, between did it on their own, about 9%, and didn't bother doing it, the other 13. Ouch. The data confirm what we already know. That what you already likely know as somebody who isn't even a teacher. Homework is not working. Students are doing it, if at all, for the wrong reason, for marks, and for the wrong person, for the teacher. Because the teacher wants to know, because the teacher asked me to do it. So it's for the teacher's benefit that I am doing this homework. And those who are doing it for the right reasons, to check their understandings, and for the right person, for themselves. And most of those, again, are mimicking. So most of those people are just mimicking. Homework in its current formulation needs to be upgraded, it has to be rebranded, and it has to become a thinking activity. So, 30 seconds to ads. I'm going to go downstairs one more, go for a water cycle. Maybe actually eat this granola bar. And I will see you all back in 3 minutes. So thank you so much for coming. Marlena, it's great to see you again. And thank you everybody else for coming on in. Like I said, be back in 3. And thanks so much for coming. I'll just keep repeating myself, it's fine.
There's more to Spotify than meets the ear. That's because video is taking center stage on Spotify, with over 300,000 video shows and 300 million users already watching their favorite podcast. With seamless switching between watching and listening, you can tune in anytime, anywhere. Got a show of your own? Upload your video to Spotify, turn views into fans, and monetize your passion.
Alright, I'm also redeeming a up, which is a look into John Gould's Maine Lingo, a wicked good guide to Yankee vernacular. I grew up in New Hampshire, and I'd always heard stories about the people from up north who typically spoke with that kind of affectation. I found out that this is an accent, and it also is coupled with a storytelling style, which is almost exclusively from a place called Down East, Maine. And Down East is the location around the town called Bar Harbor, or Bar Harbor, where Maine kind of does one of those things and juts out into the ocean. So if you look on a map, you'll see it. It kind of goes up kind of in a northeasterly direction, and then it hangs out a bit into the ocean, and then goes back mostly north again. So you'll find Bar Harbor. And not a lot of... No, Bar Harbor, Maine. So the... all of this stuff was studied in the 1960s when two guys who were going to Yale heard tell of this from one of their like classmates who was from down east, and they were just like, there's no way that this sort of thing exists. And he's like, oh no, let me tell you. And so they were like, okay, we've got to meet some people. So they went up there on a break and they talked with people from the area, and they would tell them their stories about just ridiculous things that happened around town, and like you couldn't help but believe them. Most of them were true, or at least somewhat true, or at least a little true, and they would... the way in which they told them was really the key, because they always talk about good old Virgie down the corner, Virgil, whom everyone calls Virgie, and, you know, talk about all the time that he went out and got his boat hit. Oh yeah, I remember that. Must have been about 2 summers ago. And I learned about this from their... They created several albums of stories that they had made up, but they created like this mythos. It was called Bert and I, or Bert and I, and you could probably hear a few of them on YouTube. Certainly not all. And I did manage to get my hands on like 1 or 2 of the albums, but it's not the same one that my parents had growing up, so I'm a little miffed. But there was always a guy at the Stratham Fair in Stratham, New Hampshire, who would perform stories from Bert and I don't think he was either Marshall Dodge or Robert Bryan, who were the 2 guys who actually like did the work here. I think he was just a fan. And he learned all their stuff. So it became impressed upon me to, I should probably also pass this along to anybody who might be interested in listening to it. Tonight we'll do one from M and one from L. My, M-Y. The use of this pronoun could have been entered just as well under his, your, her, or their. The habit of Maine people to presume possessiveness about a wild deer running in the woods amuses folks from away to no end. Got your deer yet? Oh, I'm all done this season. I got my deer the first day. Joe got his deer Tuesday up at the Forks. Oh, she's quite a hunter. Gets her deer every year. So, using the pronoun in order to assume possessiveness about a particular hunting quarry. And... oh, that's a good one. Okay. And next one is lightning strike. A forest fire started by lightning, and also the browned out area that remains an eyesore for years to come. A lightning strike will also be used as a landmark. Fish down the lake out to the lightning strike, but you likely won't hook anything beyond that. Lightning strike. Yeah, so there is a tendency for New England people in general, people who have been New Englanders for the formative years, myself included, to call out a particular thing, whatever it might be, as like a landmark that you can't miss it. You just make a right at. You can go make a right at the dead tree. Go about a quarter mile. So there are just a lot of instances where people will call out directions using odd landmarks, and especially landmarks that like the locals know, because oh my goodness, do you remember that time when oh goodness. You remember the Smith boy crashed his truck into that oak tree 5 years ago. Right. Well, you want to hook a left right at that tree. It is quite remarkable. I mean, it might happen other places in the country, but with that particular affectation, with that particular accent, with that particular storytelling style, it just always, to me, is very noticeable. It hangs out super, super far. And it's like, oh, that feels like home. Okay. So, on to the last section. I think this will probably take us about 40 minutes or so, and hopefully, yeah, plus the FAQ. Yeah, should get us about 40 minutes. We'll see how it goes. In the history of schooling, homework has been rebranded once before as practice. In many classrooms, especially elementary, the word practice is still used to either describe work done in class or synonymously with homework. Regardless, practice puts greater emphasis on mimicking. So you're supposed to be practicing, i.e. doing the same thing over and over, i.e. copying whatever I wrote on the board and just applying it to the new problem. Right, so we can't use the word practice to really talk about homework in that way. While still not resolving the issue of why it is done and who it's for. So, as there was a comment that was up above. Lucas said, why else would he have notes? Fatima says, isn't that what the teacher wants us to do? And Samantha says, the teacher shows us how to do it and then we need to practice it, right? So as Samantha's comment shows, when the terminology of practice was used, it increased the perception that mimicking was what the students were meant to be doing, and as a result, increased mimicking behavior. As discussed, mimicking has limitations and is antithetical to actually learning the material and engaging in the thinking behaviors that these classrooms are trying to foster. So, how do we respond? So let's come back to the notion of why homework is done and who it's for. We've seen that if the purpose of homework is to get marks and/or it's done for the teachers or the parents, it loses potential to achieve what teachers really want to achieve, for homework to be a safe place for students to make mistakes as they check their understanding. So here lies the rebranding that we need. Change the name to Check Your Understanding questions. This addresses both the need for what was it? The two things here. What is the purpose? I mean, it's right in the name. Check your understanding. Who's it for? Right? Who is it for? Check your understanding, not check me or whatever. Check your understanding to make sure that you understand it. And also, this is to be done to check your understanding, not for grades. Calling it check your understanding questions specified who it's for and what it's for. This had an immediate effect on students.
Pumpkin spice, actually. It's back. Brought to you by Starbucks.
We saw more students doing the check your understanding questions on their own than had seen with homework. And they were all doing it for the right reason. They were doing it to check their understanding, not for a grade. Even when the students were seeking help, they were now seeking to understand rather than seeking to be done. And again, this is borne out in the data itself, but also then in the interviews with the students. So he was able to solicit, why did you complete this time? Why did you do your homework 2 nights ago? Great. Why did you do it? Like, what was different than earlier? So earlier you said, right? Earlier you said you just wanted to get it done. What about now? What's different? Right? Oh, you want to understand. Oh, that's much better. Even when students were seeking help, they were seeking to understand rather than being done, and students were, for the most part, no longer talking about marks, practice, mimicking, or doing it just for their teachers and parents. But of course, you can't just rename this check your understanding questions and expect that students are just going to immediately change their behavior and stay that way. As soon as some of them realize, oh, it's just homework, we're just doing it slightly differently, they're going to, the game is up and they're going to slip back into old habits. So, how do we change this? As with other practices discussed so far, you can use check your understanding questions. The use of check your understanding questions needed to be accompanied by a slate of other changes to the teaching practice. First, questions could not be marked.
Just take a breath and take it deep to show the world that you can see.
They couldn't even be checked. In fact, there can be no overt actions on the part of the teacher to enforce the completion of these questions, whether positively or punitively. Any efforts to do so were met with immediate and almost complete transition back to these questions are being done for the teachers. In essence, if you want check your understanding questions to be a safe place for students to make their mistakes, then you have to actually keep it safe. So the safe space is making sure that they are not being graded or even checked over on these particular questions. Now, we will discuss later on how they can be leveraged in one-on-one discussions and saying like, hey, you don't understand this thing? Okay, can you get out your homework, or can you get out your check your understanding questions on that section? Do you have that, in your notebook somewhere? And if they say yes, they can find it. And if they say no, you could say, well, that might be one of the reasons that you don't quite understand what's going on, is that you didn't check your understanding. And like, I don't need to do this. I don't need to force you to do them, because this is now a natural consequence. You now don't have it done and don't understand it, and you didn't check your understanding at the time, so you didn't know that you didn't know. And again, it becomes like a self-reinforcing behavior. Okay, this was difficult to accept. In every case where we implemented check your understanding questions, 15 to 50%, although usually between 15 and 25% of students didn't bother. Now, he says, it sounds bad. Right? So 15 to 25 to 50% of the students didn't even bother. It sounds bad, but on the flip side, this meant that 50 to 85%, and usually 75 to 85% of students were doing the questions, and doing them for the right reason and for the right person. Now we contrast this with the other students before, where the homework was not marked, right? The people who didn't do it were pretty consistently 38%. The people who did it on their own was 31%. And the 29% of students who got help, so this is an overall 60% of students who at least did the assignment, are not guaranteed to have done it for the right reason or for the right person. Again, almost always they were thinking that, oh, this is for the teacher. It's not for me, it's for the teacher. That 60% who did their work and didn't cheat. I'm just lumping the cheaters in with the didn't do it group. So the 60% who either got help or did it on their own when it was not marked now improved to 75 to 85%, and they're doing it for the right reason for the right person. So it's not only a 15% plus improvement of overall, shifting, but now it's also for the correct pedagogical reason. These students actually are doing their homework and not just copying everything down, not just mimicking what they think the book is saying at them, what they think their notes say. studenting data on homework show that 75% of students were completing their homework in some way, shape, or form on the marked version. But only 10% were doing it for the right reason in the first place. When completion is the goal, it encourages and sometimes rewards behaviors such as cheating, mimicking, and getting unhelpful help. This is not to say that you can't talk to your students about them doing their check your understanding questions. Turned out to be very important, but also risky. The discourse around this needs to be focused on check your understanding questions as an opportunity to learn from their mistakes, i.e. doesn't have risk, to check their understanding, and above all else is for them and only them. We need to drop references to words like practice, which evoke mimicking behavior, and assignments, which invoke that it is for a mark or for the teacher. Right, so drop assignments and practice from this vocabulary, from the stuff that you are sending home with the students. These are check your understanding questions. Another change in the practice was that answers needed to be provided at the same time as the questions. If the check your understanding questions were truly to be seen as a way for students to check their understanding, they need something to check against. They needed answers to see if their understanding was correct. Fully worked out solutions can be provided, but not right away. We learn that when students see these before they've done the questions, some mistake their understanding of the work solution for an ability to do the same. Understandable. They would look at it and be like, yes, I follow. I understand what the process is. And they would walk away from it instead of attempting it themselves, looking at the answer. Just the answer. Is it 3? Is it pi? Is it whatever, right? Okay, well, I don't have that. Ugh. Now what? It means that they have to go back and they have to look through their work and see if they find a mistake anywhere. And if they can't find a mistake, maybe they found my mistake. It's possible. Maybe I copied the wrong problem. Maybe, who knows? Or, more likely, when I was going down the list and adding all the answers to this paper, I could have skipped one or doubled one. Because goodness, that happens. Okay, so then the homework, or the questions may be the same as what we used to give for homework, but to make doing them a thinking activity, everything around them changes. What we call it, how we talk about it, the autonomy the students have to do it, and our openness to the fact that students may do some or all, or not at all. Students may do some or all, or not some of them, or not all of them. And when these changes occur, the doing of the check your understanding questions becomes a thinking activity itself. Okay. FAQ. Usually the best part. If I don't check or mark the check your understanding questions, most of my students won't do them. Are there any strategies I can use to get them to do them? Okay, so let's assume that half of your students are doing the check your understanding questions and doing them for the right reason. First of all, these are already better statistics than what you had in your previous class, than what we saw in the studenting data around homework. Secondly, the research showed that if we start policing these questions, we will be successful in raising the number of students who do them, but also sharply decrease the number of students who are now doing them for the right reason, i.e. to check their own understanding. Of all the things we researched, check your understanding questions is one of the most sensitive to disruption. This is not to say that there are not small things that you can do to encourage them to do the questions for themselves. As mentioned, our discourse around this practice is helpful. The use of words such as opportunity are helpful, and the use of the words practice and assignment are not. In fact, are counterproductive. And add in opportunity. If you're doing this within the context of the other thinking classroom practices discussed so far, talk to the students about how your check your understanding questions is a chance for them to see if they can do on their own what they already did in their groups. Remember that this is randomly assigned groups of 3 around their whiteboards, typically vertical whiteboards or blackboards, but vertical non-permanent surfaces. In essence, if you can keep the focus on them and the correct reason for doing the questions, anything you say is helpful. For example, one teacher I worked with asked their students to discuss amongst themselves which of the check your understanding questions they thought were the most important for them to do. This metacognitive discussion had a significant impact on how many students did at least some of the questions. Metacognition is a huge topic within education circles. So it's the thinking about thinking. And yeah, metacognition is just one of those things you learn in like your sophomore education class that just keeps coming around again and again and again. We were still talking about it in Ed Psych and then Ed Philosophy up in senior year. So I don't give homework. I give my students questions to do in class, but I don't send anything home for them to do. Should I be changing what I call these questions done in class to check your understanding questions? Yes. Unlike homework, the name check your understanding questions does not specify where and when they need to be done. So the word homework itself is loaded. Neither does it specify that it must be done. This is about messaging around why and for whom these questions are done. Having said that, the research showed that as long as we're not policing, giving class time to do these questions increases the number of students who do the questions and the number of questions each of them do, on average. So much of building thinking classrooms is about collaboration. Can the students do their check your understanding questions in groups? Check your understanding questions are for students, and they have autonomy over all aspects of them. If they choose to do them in groups, we cannot and should not prevent them from doing so. And we should not control who is in the groups. In fact, if you give class time to check your understanding questions, 40 to 70% of your students will choose to do them in self-selected groups of 2 or 3. Many of these groups will choose to do them on the vertical non-permanent surfaces, your whiteboards typically, and many of them will stay in the random groups from the beginning of the lesson in the first place. They'll just go to the boards with their group because that's their group. Although they're working collaboratively, what is interesting is that the goal remains the same, for them to check their own understanding. and this comes with a very interesting discourse as they strive to learn from each other. I don't get it. Well, I still don't get it. Okay, well, I think I get it. Give me another one and let's see if we got it. Although they're working together, the goal remains fixed on checking their own understanding. So you say that we can give worked solutions, but not right away. Should we do this? If so, and if so, when? First, make sure we're all on the same page. We need to differentiate between answers and work solutions. X equals 7 is an answer. It reveals nothing about how we actually arrived at the solution. The research showed that giving worked solutions became more and more important the more complex the questions were. This corresponds loosely with an increase in grade level, but not exactly. The research also showed that worked solutions should not be given out until the students have had a chance to work on the questions, check the answer that they arrived at against the answers provided, and, if needed, retry it, possibly several times. As mentioned above, if we give the work solution as the same time as the question, some students will read the solution and think that because they understand what is happening, they will understand how to do it on their own. However, if the work solutions are provided the next day or a few days after, the students now have a chance to compare their thinking with the worked solution, as well as go get help with any questions that they're unable to resolve on their own. So if anything doesn't match up, why doesn't this match up? Interestingly enough, if a student comes up with a different method of doing stuff, they'll need to check to make sure that the method is sound. Many teachers I worked with gave out worked solutions by posting them on the class website or portal a couple days later. I have parents asking for homework or practice. How do I deal with this? Begin by communicating with them about why you give homework and how these reasons are embodied in the name Check Your Understanding questions. Explain that the questions that may or may not be coming home are to be treated as safe space for their child to make mistakes, and that the purpose is for them to learn from those mistakes. If they insist on having more questions for practice, you can tell them that ample practice questions can be found on the internet. But they will not be part of your teaching practice. I teach primary grades and I do not typically assign homework. Should I be doing Check Your Understanding questions? Yes, but I'm willing to bet that you already do it. Every teacher that I have ever worked with from kindergarten through grade 12, gives students questions to do irrespective of what you may call them. You're likely giving them as a way for students and yourself to check their understanding. Okay, so here we go. Alright, so the macro moves. Really, there's just the one. Give your students the opportunity to do Check Your Understanding questions. Okay, the micro moves for this are the things that I already wrote over there. So, do not check, do not mark, or grade. Do not ask. Do not say the word assignment or practice. Phrase this stuff as this is an opportunity for you to check your understanding. This is an opportunity for you to work on this and see if you understand it. See if you have any questions that you can bring to your groups. Ask any questions of me that you want. All that good stuff. Right? Provide no context answers at the same time as the questions. And provide worked out solutions later on. You know, give or take 1 to 3 days, something like that. Give students the opportunity to discuss with groups which of the questions they find important and why. Okay. So those are our micro moves for this one. That's not going to help very much. That's all right. All right, some questions to think about. So, what are some things in this chapter that immediately feel correct? Well, certainly he's got a handle on what's going to work for homework or not, i.e., what are students going to do? Obviously, he's done a whole bunch of data for it. So, getting the students to become intrinsically motivated is, I think, something that's been my goal for quite a while. Basically, as soon as I heard the phrase intrinsically motivated. So trying to get the students to do stuff because it's the right thing to do for them, for themselves. Because they're going to then want to, pick up the small weights and start building those muscles. They're going to want to start working on these problems because it's going to help them understand better. Not just because they're doing it for me, or they're doing it for their parents, or they're doing it because it's what's graded. Which of your students do their homework and which do not? So you could pretty much clearly identify which students were going to do their homework in my classes because they would typically be labeled as the smart ones. The students who were, again, already intrinsically motivated. The ones who were keyed in to all of these little nuances of education. The ones who wouldn't, again, you find out later that, well, they just don't understand. Cool. Why didn't you go to all of these other places? They make the excuses that we saw here. I just don't have time. There's no convenient hours. Yes, the labels. There was a there was a meme that I saw a long time ago, which was a headline from, I don't even remember exactly where, but it was like a guy holding a bird like this, and it's yellow. I mean, just like full on yellow all over. And it said, rare exotic bird captured at local restaurant, or captured in town, something like that. Found out to be seagull covered in curry. And somebody said, "Oh shit, that's me." As in, like, this is the entire, smart kid thing. Like, you find out that you're not really an exotic bird. You're not you're not the exotic bird that you thought you were, that your parents always told you were, that your teachers always told you that you were. You're just a seagull covered in curry. I've still got that one saved on my phone because every time I think of it, I laugh. But yeah, the labels are insane, and everybody knows at this point, pretty much, unless you were one of those people who bought into it, and a lot of people bought into it, but if you were one of the people who were proud of your particular label, then most of the time you just kind of go with it. But like everybody else realizes at some point, I can't remember where it was, there was somebody's kid who went from a school of like, 100 total to a school of 1,000 total. And they went, "Oh, I'm not actually exceptional. It's just that there's a much smaller pool to choose from." In like, the little tiny school. And, most of us who did this exact same journey at some point. I went from, a high school of 1,200 to a college of 20,000. Same deal, right? You realize, oh, okay, I'm not actually that smart. It's just that, there wasn't quite a wide, vast array of people. I met up with one of my elementary school classmates. Now, granted, she was also in my middle and high school as well, but I never saw her because she was off with that group, the popular kids or whatever. I lost track of her, and I had assumed, like a big asshole that I was, I assumed that, she just went off and was being a popular kid or whatever. And I ran into her senior year at UNH, and she had started, I think she was just ending her sophomore year. So, like, she was at my same grade level all through school, and then took a couple of years off because she needed to go figure out some stuff. And pretty much from that moment on, I was like, hey, there's no fault here. The fact that you are here, I was just kind of thinking to myself, the fact that you are here and you are, like, working on stuff, and she was in the social work program, I was like, that is so needed. And, like, knowing her particular situation, I was like, that completely makes sense. Because, like, she had to deal with social workers, and they were not particularly good. And she was, as soon as she got into college, she was like, I'm going to fix this. you know, I'm going to do better. And just talking with her for like 5 minutes in the hall, I was like, that is so wonderful. You know, I am just glad to see you at this point and talk to you like a normal adult. Because for so long, it had just been like, she was with that group, where it was just like, I don't know what you're doing, but it's nothing that, you know, nothing that relates to me at all in any way. But anyway, you feel the same way about Mario Kart? Oh my god, yeah, you find just a regional group and it's like whoosh. That may have come across as like somewhat condescending, and I'm sorry if that did for anybody out there, but you know, the advent of online gaming. Oh goodness, yeah, yeah. It wasn't. Yeah, I'm just gonna dig the hole anyway. Yeah, I was so happy to see her. And again, I'm going to seem way worse than it probably was, but I had kind of written her off as somebody who was going to be a townie for the rest of her life, and somebody who is going to, I don't know if anybody knows what townie is, but anyway, somebody who just wasn't going to really do anything or go anywhere. Somebody who is content. Yeah, I can't make that good. I had seen some of my peers that I thought were destined for really cool things. And they were perfectly happy to end up, I don't want to say like not doing anything, but like you get the feeling that they were perfectly happy to do like to be a very minor cog in the workforce for the rest of their life. They didn't want to aspire to become a manager or own their own business or like go seek out and discover something about themselves. Like I said, this is going to make me seem like a complete asshole, and let's be honest, I am probably. But like, yeah, they didn't seem like they were going to do much in the way of like cooperation and helping other people around them. It was just kind of like, I'm in this for me. I'm in this for getting by. And like, if you have to get by, that's fine. But at the same time, like, I really want people, and it's probably because I'm an educator, I want people to aspire to more eventually. And as it turns out, like, owning your own business is not very hard in terms of like getting that done. Doing the actual work once you've got the business is very hard. But like, you know, coming up with an idea, coming up with a business plan. I have you know, classmates who are semi-illiterate who were able to do that because they found people who could like help them out and get them in the right, get them support in the right way that they needed. And it was really cool seeing a bunch of people do that. I'm just gonna keep digging, so. And again, with her, it was like, I am so happy that you are aspiring. Regardless of what it was. I didn't even care. But to just see her so happy was the other thing, right? Seeing her happy was also really just, it made me happier. Because I was so worried at some point in my life about kind of the direction that she was headed in, but... Back to this. Of those who do their homework, why do they do it? Again, he pretty much gets it. Like, Liljedahl understands it pretty fully. These students, through their interviews, told him that they were really only doing their homework because the teacher told them, or it was because it was 4 marks, and therefore it's for the teacher. Sure, they benefit from the grade, but the teacher, it's for the teacher's benefit to understand where they deserve to be graded. Yeah. Contrast your answers previous to the reasons why you want your students to do homework. I mean, again, he knows what he's talking about. I wanted my students to do all that for the reasons that I gave above. That, they should be doing this for themselves. They should be doing this because they're practicing their skills, sure, but they're reinforcing the learning that we did in class, where we talked about how all these pieces fit together. And we want to give the students some feedback, make sure that they understand the connection, right? Make sure that they actually understand it. And if they have any questions, we can kind of guide them into figuring out what those questions might be. In this chapter, it was mentioned the practice invokes mimicking. What are your thoughts about practice as an effective learning tool? And is this what you want your students to do? Again, I want them to, analogy to weightlifting, I want them to actually do whatever is needed to get them from where they are to where they need to be. Again, I'm giving them 5-pound weights and pointing to the 60-pound weight and saying, you're going to be doing that in a month. So, get working. What do you think about the reality that some students may choose not to do or not do all of the check your understanding questions, and how do you cope? I didn't have a problem with it before, and so that was when it was graded. I would wait and see what homework came in, and then I would grade the people who did come in, and then pretty much if I handed back the homework, nobody was able to hand in that one. If I handed it back, nobody else can hand that one in. Which honestly was at least a week anyway, so whatever. What do you think about the reality that some of your nope, we just did that. What are some of the challenges you anticipate you will experience in implementing this strategy? Just pushback, generally speaking, right? Like, why isn't this counting for my grade? Why isn't this whatever? But the larger overall idea is that we're going to attempt to tell the students that, look, this is not for me. This is to check your understanding. And with the rebrand, most of the questions are going to be gone, right? Like, these are to check your understanding. Why don't you work in your group and try to figure out where the hang-ups are? And that way you can figure out where you need extra help, where you need extra support, and then I can be part of that. Or you can bring that information to your tutor, and that will be way better. The other problem that might exist is pushback from the administration, because they want to see, in theory, right, who's got. They might want to see gradated grades, so that instead of, oh my goodness, your only grades in this class are like exams, right? That works for college. Especially does not work K through 12. You need to balance out where you get your grades from, right? As is discussed later on in this book, the grading that we do is completely and utterly different. So it is not going to be about getting a student to regurgitate the information that they just learned. It is not going to be about them showing off a skill that they know how to do. It is going to be about a series of learning events that give them opportunities to show off what they know. And then to show where they still have hang-ups. Now, in theory, if you've told them well enough, they know that, the exams are kind of their last chance. That's all you got. But realistically, there are other ways to get those particular, and this does come down to checkboxes eventually, but it's essentially like you can earn new levels in each of these different concepts as you go further and further into the course and into your learning. And you can even get check marks after the, exam that corresponds with that particular objective. And students can, if they already know what their objectives are, what grades they have on other objectives, again, we'll talk about that later, then they can just decide, like, I'm going to work on these 3 objectives right now, and then, skip the next 5 because I've already got them. I've completed them to the level that I need, so I don't need to do the next 5 questions. It was a little wasteful, unfortunately, in terms of, some students literally just did, a couple of questions on page 1 and a couple of questions on page 5, and they did nothing in between. And so... because they were good. They already had stuff in the middle. So... at any rate. So try this. Rebrand what you would previously refer to as homework or practice into a set of check your understanding questions. Give it to your students with answers. Emphasize how this is an opportunity for them to see whether they have understood what happened in their groups. Do not collect, mark, do not mention it in terms of hey, have you done that? Because, again, they'll think it's for you. And the next day, provide worked out solutions for them to use to check whether they really understood. Okay. Chapter 8 for next time. So next Monday, we have how we foster student autonomy in a thinking classroom. So, got a few little pictures of people working at boards and pointing to, one group pointing at another one that has more work than them. It's a hint. On Wednesday, tomorrow, Tuesday, we'll be doing 9 Souls. So if anybody is interested in watching the Tai Chi kitty, do some more Tai Chi against the bad kitties of New Kunlun, then we will be doing that starting around 9:30 again, hopefully. And yeah, we'll probably do a Tai Chi break tomorrow. So, so then we'll also on Wednesday work on cracking the GRE. So that's going to be our concept day, so if anybody wants to come in with questions, anything like that, feel free to do so. I will be around answering math questions, and that's mostly just a source of inspiration. So if anybody wants to have any particular questions answered, I will always do that. As you saw earlier today, we did stuff on quadratics. So we were talking about how do we make quadratic functions, do transformations, and then eventually got into like the general and vertex forms of this thing and how they're related and how we get the quadratic formula. That's actually a really short proof if you know how to get there from one to the other. It's really pretty amazing. The, correct way to do it from general form to going directly to the solution is gross. I don't like doing completing the square when you have to do it with variables. It's really nasty. And 99% of the time, I was not doing it in class. So when I transitioned to learning mostly in terms of transformations, then I was able to directly show the link between these two things. And students were like, oh, what? How does that happen? How does that exist? It was really cool. The looks on their faces were priceless. And almost every day I could make somebody in the class go, okay, and then I believe this weekend is Dash. Anybody who's interested, in your area, there is likely a puzzle hunt going on. There are, I believe, 13, 14 cities. This is the first one they've done since COVID, I think. It took a few years to get it going. It is in London, or for me. For me, it's in London. It used to be either, like there was a Balto Wash, so somewhere between Baltimore and Washington, there was a group that did Dash. There's also one in Boston, one in... well, we got a bunch on the West Coast, bunch on the East Coast, and a few in the middle. So, like I said, I believe it's 13 or 14 cities around the world, because they opened the one in London. So the acronym is different area, same hunt, Dash. You probably could go to playdash.org if you're interested, and it usually has puzzles that range from like pretty simple to I don't know how to actually start this, but most of the time it's doable. Let's see, we're also going to go see Don tonight, so we'll see where he's going here. I think we're doing all right. Yep. So Don Factorial, is doing some math tonight, so we'll go see him. So my point for bringing up Dash is I will likely not be here on Friday or Sunday. So that means it's probably going to take out... Actually, I might be here on Sunday. It's probably going to take out my Against the Storm playthrough this week. But I should be back in time for a Satisfactory Sunday. In that we will be home. It's just a matter of whether or not I feel like it. So anyway, hope you all have a good week. Thank you so much, everybody, for coming. And let's go over and see Dawn. So have a good night. My name's Obi-Wan Pez. This is Ensign Blake Spachenko. Catch you later.